So we can do one more example. For example, if we have a j omega here, then we can still have the load here. Okay, so we can calculate the V out here. The V out will be equal to the j omega L plus R, and it's R here. So it's V in. Okay, so let's calculate it. Really calculate it's 1K ohm here, which is 10 to the 3, and we have j omega here, the j omega, and this is 3 Henry multiplied by 3 at 10 to the 3. Okay, that's a V in. No, this is V in. So as we can see, okay, if omega goes to 0, then V out will be equal to V in, right? But if omega goes to infinity, then V out will goes to 0, right? So obviously this one is what is a low pass filter. So comparably, you see this one, if we put a capacitor here, this one is a high pass filter and the first order. And this one is the second order. No, this one is also first order. But this is a low pass filter. Okay, so as we can see that the capacitor inductor actually just act just reversely, because that in the capacitor, the impedance is j omega c 1 over j omega c, but for the inductor is j omega L, right? And how to find the cutoff frequency FC is when omega multiplied by 3 will be equal to 10 to the 3. So that means 2 pi f will be equal to 333 approximately, and it's 6.28. F will be equal to 333. Then the cutoff frequency will be 333 over 6.28, which is approximately 50 hertz. Okay, means the 50 hertz will be the cutoff frequency, and so that we can draw the frequency response something like this, and this will be, since a low pass filter here, and we have the let's say around 60 hertz, and the slope, since it's first order, so it's minus 20 dB per decade. So this will be the frequency response. And of course, we can have much more difficult one, which is the second order low pass filter or high pass filter. For example, this one, when we put capacitor here, well, actually this one is a low pass filter, and this one, so this one high pass filter. Okay, and same thing, we got the output will be here, and I try to show you the example by calculating the solution of this. This is much more difficult, and I'm afraid that I might be 100% correct. But let me show you that this is my note. Okay, this is the second order, the high pass filter, and the formulation is no different to the ordinary circuit using resistors. So, for example, we can say that we can assume that we have the two current I1 and I2, right? And we use this loop. We use this loop. We can have the first equation like this formula, right? V1 V in will be equal to I1 multiplied by the impedance of the capacitor, and also we can have this one. Okay, the I1 minus A2 and multiplied by the R1. And for the second one, for the second equation, I use this one. It's also V1, okay, but it passed through the first capacitor and also passed to the second capacitor, and then finally the RL. Okay, so and I try to rewrite equation one. So after the equation one is rewritten, then this will be the equation one here. And I try to eliminate I1. And why I want to eliminate I1? Because that all I need is the I2 and the RL multiplied by the RL. So I try to eliminate the I1. So I multiply the third equation by this one. Okay. And the result will be this one. The result will be this one. Well, actually, it's quite complicated. Okay. Well, actually, it's quite complicated. Okay. That should be correct. And then I can rewrite this one to this one here. Okay, I for the left hand side, I try to multiply the numerator and the denominator by j omega c1, and then I can have the fourth equation. I subtract the second equation by the fourth equation, and this is the one. So the left hand side become this one. This will be the left hand side, and this will be the right hand side. Wow, a bunch of this one, and after, and then I can put this one here. So this one goes here. Okay, and this one goes here. This one goes here. Okay. Okay. And then I have to arrange the right hand side and the right hand side so that finally I become something like this I2. And finally, I find the I2 will be this one quite a lot. And the V out, the V out will be the I2 multiplied by the R2, right? So I put R2, no, RL here. So we have the RL here. And finally, the total equation becomes the second for the nominator. I have a very simple term, something like this, with omega square multiplied by the C1, C2, R1, and the RL. But the denominator is a little bit complicated. The denominator is this one, okay. But the denominator actually is a second order polynomial. So this one should be a high pass filter. Okay. When omega goes to infinity, the V out will be equal to V in. But when omega goes to 0, the V0 will be VR will be 0. So it looks very complicated, right? But there are some formula to calculate something like this, but this is not the purpose of this course. So I just show you that how to calculate the so-called transfer function of this one. So that means that this we usually call this one as our transfer function. Bunch of this one is our transfer function involving the omega and all the value of the components.